Hello everyone. In this video, I will cover section 2.7 position vectors, section 2.8 force vector directed along a line, starting with the definition of the position vector. Let's say I have 2 points in the air, point A and point B. And how do we describe a vector that passed through point A and point B? Let's say being A is the starting point and B is the ending point. So we're going to use the coordinates of the points. Coordinates of point A, XA, YA, and ZA. Also, the coordinates of point B, XB, YB, and ZB. To calculate the position vector directly from A to B. A is the starting point, B is the ending point. We are going to take the coordinates and you will do the coordinate ending point minus the starting point. And be careful with the notations over here. You have R, AB, you write your starting point first and ending point. So it's passed through AB, start from A, end at B. And then when we calculate the position factor, you're going to use the coordinate of the ending point minus the starting point. Okay, so note over here, always subtract the tail coordinates from the tip coordinates. So ending point minus the starting point, xb minus xa for your I component, yb minus ya for your j component, and zb minus za for your k component. So a short example over here. So if I have a position vector start at A and at B, you're gonna have this RAB, right? And then use vector RAB divided by the magnitude of RAB. That will give you the unit vector of RAB. And once you get the unit vector of RAB, multiply by the magnitude, this force right here is magnitude of the force, then we can get the force F being a vector, force vector. So now you have the magnitude with direction. Let's take a look at an example more specifically. This pole right here, we have A as the starting point. And if I want to find out force vector AC, okay, we know the magnitude of the force 420, but we do not know the direction. Okay, so we need magnitude multiplied by the direction. Okay, so first thing first, we're going to need to find the position vector. For A right here, we want to find out what is the coordinate of this point A. The point A, because it's on the z-axis, you have 0 for the x component. For the x coordinate, it will be a 0. For your y, see, because it's on the z-axis, your y is 0 as well. And your z, it's on the positive z, you have a value of 6 meters, so I put a 6 here. That is your coordinate for your A. And then for your C, it's down here, right? X is this length right here. So going from here to here. That length is 2 meters, same as that. So it's 2 for your coordinate X. And then for your Y is this much, which is the same as distance here, right? So that will be 3 meters for your Y component, or your Y coordinate. And then the Z, because it's on the XY plane, that's why the Z component is going to be 0. Z coordinate is 0. Okay, so this is the C and this is the A. To use the coordinate of A and C to calculate the position factor AC. Remember in the several slides before, we talk about it needs to be the ending point minus the starting point. So we take this RAC, right? In order to get your RAC, you're going to do the ending point, which is C. So you have XC minus XA for your I component, and then YC minus YA ending point minus the starting point, and then keep going. I'm running out of room. You have ZC minus ZA for your IJK component. Okay, now you plug in the values. RAC will equal to the C, look, 2 ending point minus the starting point. 2 minus 0 gives me the I, and then 3, the YC minus YA, that would be a 3 minus 0 for your J. And then you have ZC, which is a 0. ZA is a 6. 0 minus 6K. And then simplify it. And then you will have RAC equals 2I plus 3J minus 6K. Okay, that's where that comes from. Get the coordinate of A and C, and then ending point, subtract the starting point. After we get the position vector, we're going to use the Pythagorean theorem. So really, it's going to be you take all these, right? The 2, the 3, the 6, square, 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 and then square root. That's what this is doing here. And then to get the magnitude of the position vector. And then the position vector RAC divided by its magnitude, that will give me the unit vector that passed through point A and point C. Okay, so over here you get the unit vector. So we know the magnitude is 7, right? Originally our RAC equals, let me take a look, 2I plus 3J, 2I plus 3J, and then minus 6K. Okay, so that means the unit vector AC, it's going to be, we're going to take that divided by 7. So you have 2 over 7 I plus 3 over 7 J minus 3 over 7 K. That is the unit vector. Okay, and because force AC passed through the point A and point C, so you're going to take the magnitude of that 420 multiplied by this UAC. Okay, so FAC, what I mean is the vector is going to be, that's vector, unit vector. Force FAC, it's going to be magnitude, which is 420, multiplied by the unit vector AC, where the unit vector is going to be what we just did. And it's written in this PowerPoint as well. I'm writing it so that to help you understand better. And then you distribute that 420 in there. That will give you the final result on here. Force vector with magnitude and direction. Group problem, same thing. So if I know the magnitude of FB and FC to be 460 Newton and 700 Newton, we'll want to find the magnitude and the direction, magnitude in the coordinate direction angles of the resultant force. Okay, and again, force 560 Newton and 700 Newton, the FB and FC magnitude is given to you. However, resultant force, you cannot simply add them together. It's not going to be the numerical addition because they are vectors. They have their own direction. They are not pointing toward the same direction. You cannot add them together directly. So first thing first, we're going to do the unit vector again. So coordinate for your A, point A is going to be coordinate. Your X value is 0. Your Y value is 0 as well because it's on the Z axis, and then it's being 6 meters elevated from the bottom, so you have 006. And then your point C again over here, your x value is this much, okay, which is the same thing as this one, so it's 3 meters for your x value. And then your y value for that C is going to be this, it's going to be this much, and it's the same thing as this much, which is 2 meters. So you have 3 2, and it's because it's on the xz plane, your z value is going to be a 0. B, coordinate B over here. Okay, again, your x value is this portion, which is the same as this portion, 2 meters. Your y value for that B, it's this portion, and it's the same as this portion. Now be careful, it's going in toward the negative direction of your y, so it's -3. And then your z component, because it's on the xy plane, you have a 0 for your z component. Okay. What you're doing next to find the RAB and RAC, you are going to take the ending point minus the starting point. AB, for example, you are going to, so RAB, you are going to take the, so we have the I, the J, the K, right? So where does it come from? It will be the coordinate of B minus the coordinate of A. So you have 2 minus 0 for your I, negative 3 minus 0 for your J, and then 0 minus 6 for your K. And that's how you get your RAB. Same thing, similarly, if you want your AC, you will have your I, your J, and your K ending point, which is C, minus the starting point, which is A. So 3 minus 0 gives me the I, 2 minus 0 give me the J, and then 0 minus 6 give me the K. That's how you get the position factor RAC. Next one, we're going to find the magnitude using this Pythagorean theorem, finding the magnitude of RAB and RAC, which both of them come out to be 7. You take each one of the 2, the negative 3, the negative 6. This one will be 3, 2, and negative 6. Square each one of them, and then square root. And then you're going to find the unit vector. So in other words, take the position vector divided by its magnitude. So your RAB, so let me use a different color to green. Okay. One additional step I would like to put here is that this is your unit vector AB. Okay. So UAB, unit vector AB, equal to unit vector equal to position vector AB divided by RAB, its magnitude. Same thing as unit vector AC, this one right here will be position vector AC divided by the magnitude AC. Okay, so meaning this one is your unit vector AC. Okay, I put that arrow on the top means it's a vector. Now, if you have the unit vector, AB and AC, multiply by the magnitude of each one of the force. FAB, the magnitude is 560. FAC magnitude is 600 Newton. So putting this two together, magnitude multiplied by the direction of the unit vector, right? Direction AB. This one's direction AC. That will give me the force vector with magnitude and direction. Hope that helps you. Next thing, once we get our force vector, every single component, the I component, the J component, and the K component for both the AC and the AB together, you're going to add them together. Now you can do your addition. Your addition is going to be, let me use another color. You are going to take 160 and 300, add that I together. That will give you 460. That's where that 460 comes from. Next one, let me try a different color. Let's go with this. So you have negative 240 and 200. Add this two together. That will give me negative 40. That's where that one comes from. Okay. And then next one is, let's go with the yellow, orange. You have negative 480. This one is negative 600. Put them together. That's negative 1080. That's where that comes from. So you have your I, the J, the K, adding the force factor together. And then using your Pythagorean theorem, you get the magnitude of the force, and then each single one of them, remember this was in our last video, your alpha, cosine, inverse cosine 460 over 1175. What you're doing is the 460, this part is going to be cosine inverse of F resultant force, X component divided by F resultant force. Okay, same thing. So the beta over here is cosine inverse of F resultant force Y component over F resultant force overall. And then the gamma is cosine inverse F resultant Z component over F resultant. Okay, so that gives me the angle. Um, that gives me the angle for every single one of them. And then alpha, by definition, one more time, we talked about this before, but just to give you a quick refresh of your memory, alpha is defined as the angle between the x component of the resultant force and the resultant force overall. Beta will be the angle between the y component of the resultant force and the resultant force overall. And gamma will be the angle between z component of the resultant force and the resultant force overall. This is all I want to show you in this video. Hope that helps you. Thank you for watching.